Welcome to The Explainer. Today we're going on a seriously fascinating journey, starting from the raw physical stimuli of the outside world, all the way to the neurological superhighways of human perception. We're going to uncover exactly how your body detects the universe around you, and how your brain actually builds the reality that you experience every single second.
Here's our roadmap for today. We'll be hitting beyond the basic five, the chemical senses, light, sound, and balance, touch and proprioception, the cranial nerve highway, and finally, making sense of sensation. Let's dive right in.
Section 1. Beyond the basic five. Get ready to rethink perception and pretty much everything you were taught in grade school about how you experience the world. So, do humans really only have five senses? I'm sure you remember the classic paradigm, right? Sight, smell, touch, taste, and hearing. But as it turns out, that traditional list barely even scratches the surface of our true biological capabilities.
Instead of thinking in terms of just five experiences, we really need to think in terms of our biological hardware. What we actually have are these five distinct types of sensory receptors. Their whole job is a process called transduction. Now, that's just a fancy word for converting physical and chemical energy from the outside world into electrical action potentials that your nervous system can actually understand. We've got mechanoreceptors for pressure and movement, thermoreceptors for temperature, pain receptors for tissue damage, chemoreceptors for chemicals, and photoreceptors for light. So the absolute crucial point here is that our perception is fundamentally categorized by the type of stimulus these tiny biological transducers are built to catch.
Now, anatomically speaking, we organize these receptors into two major categories. On one side, we have the special senses. These are mediated by relatively complex sense organs localized entirely in your head. Think your eyes, your ears, your taste buds, and your olfactory system. On the flip side, we have the general or somatosensory senses. These are widely distributed, literally scattered throughout your skin, muscles, tendons, joints, and viscera. They act as your whole body detectors for touch, pressure, heat, and pain.
Moving on to Section 2, the chemical senses. Let's look at taste and smell, and how we interact with the molecular world around us. We basically have two main chemical detectors working in parallel. First, you've got olfactory cells situated way up in the roof of the nasal cavity. When you breathe in, chemical odor molecules dissolve in the mucus and stimulate these tiny olfactory hairs. Then, you have the taste buds embedded right in the papillae of your oral epithelium. They act as contact chemoreceptors, constantly sampling the food chemicals dissolved in your saliva for sweet, salty, sour, bitter, and umami.
For a really long time, it was this common belief that the human sense of smell was somehow way inferior to other mammals. Well, actually, scratch that. 1 trillion. Recent studies suggest that the complex networks of the human olfactory system allow us to theoretically discriminate at least 1 trillion different olfactory stimuli. That is just a staggering level of chemical resolution.
Section 3. Light, sound, and balance. Now we're going to transition from chemical molecules to processing waves. The human eye is an absolute marvel of biology. Seriously, think of the eye as a highly sophisticated camera. The cornea and lens act as the optics, focusing the incoming light, but the real magic happens at the back, on the retina. The retina basically acts as the film of the camera. It's loaded with specialized photoreceptors, rods for dim light and cones for color that transduce that light energy into a neural picture.
So, what you really want to remember is this exact sequence of events. Light hits the retina, it's instantly converted into neuronal activity, those signals are bundled up into the axons forming the optic nerve, and then they're shipped off to the visual cortex. And the visual cortex is essentially the brain's own Photoshop software, rendering shape, color, depth, and motion out of those raw incoming electrical signals. Now, the ear is famous for hearing, obviously, but it actually has a massive secret double life. The inner ear doesn't just do audition, the vestibular apparatus gives you your sense of balance. Those little loops are the semicircular canals which respond to the rotary movements of your head. Below them, you've got these tiny stones called otoliths that sit on hair cells, physically pulling on them whenever gravity shifts. Together, these mechanoreceptors give you your sense of balance, or equilibrium.
Section 4. Touch and proprioception. It's time to step away from the head and look at the general somatic senses distributed across the vast landscape of your entire body.
Your skin? It is not just a wrapper. It is essentially a massive, highly complex sensory organ, packed with different, highly specialized mechanoreceptors. You have Meissner's corpuscles sitting close to the surface for light, fine touch,
Pacinian corpuscles situated deeper down to detect heavy pressure and vibration, and free nerve endings that basically act as your body's alarm system, firing off signals for pain, heat, and cold.
But what about the inside of your body? Enter proprioception. This roughly translates to the receptor for self. Think about it. Even with your eyes completely closed, you know exactly where your arms and legs are, right? That's because muscle spindles and joint receptors are providing continuous, real-time feedback to your brain about the angle of your joints, muscle stretch, and your overall posture. It is the hidden internal sense that keeps you from falling over every single time you take a step.
Section 5, the cranial nerve highway. How does all this highly localized data actually reach the central processor?
Well, a huge chunk of our perception of the outside world is mediated by 12 cranial nerves. You can think of these as vital, high-speed fiber optic cables bridging our special sense organs directly to the brainstem and higher brain centers. You have the olfactory nerve for smell, the optic for vision, the vestibulocochlear nerve carrying both hearing and balance data, and several others routing taste and facial touch.
And notice the clear division of labor when it comes to the general sense of touch. It's pretty wild. If a fly lands on your cheek, that low-threshold mechanosensory info zips right to your brain via the trigeminal somatic system, specifically cranial nerve V. But if that same fly lands on your arm, that signal takes a completely different route, traveling way up the spinal cord through what's called the dorsal column medial lemniscus pathway. It is just a beautifully organized dual highway system. Section 6. Making sense of sensation. For our final section, let's explore the ultimate destination. How does the brain take all these isolated, fragmented electrical signals from the eyes, ears, nose, and skin and integrate them to form your seamless, conscious reality? First, check out this unique architectural quirk in our brain. Almost all sensory information has to pass through a central relay station called the thalamus before it ever reaches the cortex. But not smell. The olfactory system has a VIP shortcut. It completely bypasses the thalamic relay and projects directly into the amygdala and piriform cortex. This direct hardwiring is exactly why a specific scent can so rapidly and often subconsciously trigger a super powerful memory or emotion. And as the brain integrates all these incoming signals, something truly magical happens. It's called the super additive effect of multisensory integration. Basically, our perception is absolutely greater than the sum of its parts. If you see something and hear it at the same exact time, the neural response in your brain isn't just vision plus audition. It literally multiplies, creating a significantly stronger and faster reaction than either stimulus would alone. Which brings us to perhaps the most mind-bending example of sensory integration: food. We so often confuse taste with flavor, but taste is really just what happens right on your tongue. So, I want to leave you with this provocative thought. Flavor is actually a brilliant multimodal illusion constructed by your brain's orbital frontal cortex. It perfectly synchronizes the taste from your tongue, the aroma from your olfactory system, the texture from your mouth's touch receptors, and even the visual appeal of the food. So the next time you sit down to enjoy your absolute favorite meal, ask yourself, are you really just tasting it? Or is your brain putting on an incredible multisensory show? Think about that and keep learning.